The first set of exercises that you've just completed taught you about the notion of variables. We then introduced arrays, loops, and plotting. We distinguished between variables and these three other notions, however, and we said that understanding variables is far more critical than understanding arrays and loops, because you simply cannot write code without using variables. You can write programs without using loops or arrays. You shouldn't though, as your programs will be better, i.e. shorter, if you use these ideas. I mention this again because in this exercise we are going to introduce a second critical concept in computer program, the notion of a function. As with variables, you cannot really write programs without using functions. So we really can't continue until we have addressed, in this video, the business of what functions do in computer programs. With that in mind, let's quickly revise what we have learned about variables. We have learned that variables are labeled spaces in the computer's memory that have a state. This is useful as values can be stored in the state of a variable. To demonstrate this idea, we introduced this figure showing the 5 variables called A, B, C, D, and E. We said that the state of the variable was the color of the box, and we said that we can tell Python to change the state of particular variables. In other words, we could write commands to change the state of the variables B and D from blue to red, as shown here. We did not discuss, however, what it is that is doing this change of state. The answer to this question is a function. A function is nothing more than a set of instructions for changing the state of the variables. You have thus already used many functions. Whenever you write a equals 2, you are calling a function that sets the state of a variable a to 2. In short, in any computer program, everything that stores data is a variable, and everything that does anything is a function. Critically, there are 2 types of function that we might use. There are the ones that we have already used, which are built into the programming language. As we will see in these exercises, there are a lot of these pre-written functions we can use in Python. We have already seen how we can use pre-written functions like pltplot to draw graphs. There are also pre-written functions for calculating standard mathematical things like exponentials, sines, cosines, and tans. Many of these pre-written functions are contained in libraries which we can import into our program. We have also already seen how this can be done. I'm sure you will have noticed the commands shown on this slide at the top of the programs you have written thus far. These 2 commands import plotting functionality from the matplotlib library and maths functionality from a library called numpy. When these commands are present, if a command is preceded by plt, it means we are using something from the library called matplotlib. Similarly, if a command is preceded by np, it means we are using something from numpy. Notice finally that these libraries also contain variables. When we import numpy, for instance, in this way, we create a variable called np.py, whose state we can use if we need pi to calculate the area of a circle, for instance. The other types of functions we use are the ones we write ourselves. This slide shows an example of how to define and use a function. There are 2 important parts to this code. The first part is the function definition, which appears here. And within this function definition, we explain what the function does. The second part of the function is the function call, which is shown here. The code within the function is only ever run if it is called. In other words, if our program just contains the definition of the function at the top of the slide without any function calls, then these lines of code do nothing when the program is executed. What is the point of writing a function, you may ask? Well, suppose that we have to repeat the same action on different variables. We can write a function definition once and then call it multiple times and thus write less code. Within the function definition, there are a number of important things to note. Firstly, all the indented code after the first line that contains the def is part of the function. This is the code that is run when the function is called. We can pass data from the main program to the function by using the function arguments shown here. When we call my function using the command at the bottom of the slide, the variable myarg1 is set equal to 1, and the variable called myarg2 is set equal to 2 within the function. If we create variables such as var here, we cannot access these variables once the function has finished running. If we were to write ll equals var after the function call here, for instance, our program would return an error, as var is not defined outside of the function. The only values that we can get from the function are those that are explicitly returned in the return statement. Here, when we run the function call at the bottom of the slide here, the net effect is that the variable called output is set equal to 3. The reason this happens is that my function is called with myarg1 equal to 1 and myarg2 equal to 2. Var is then set equal to 1 times 2, which is 2. New arg is set equal to 1 plus 2, which is 3, and this value is returned in the output of the function, which is what the variable called output is set equal to. I hope that is reasonably clear and that the exercises will help you to better understand, because as discussed, understanding both functions and variables is really critical, both for computer programming and maths in general. To summarize, variables store values in their state, and then functions then change the state of these variables. Once we understand this idea, we can then construct programs to do many things. Thanks for your attention.